Determine the correlation. See example 1 on page 247. So example 1 on 247 is right here. And you can see we have hours in our x-axis and we have wages in our y-axis. And we could see that if somebody works 8 hours a week, they earn $130. If somebody earns 16 hours in a week, they'll earn $230, and so on as we move our way down to 40 hours in a week, and they'll earn $600 that week. So we want to identify whether this correlation is positive, negative, or there's no correlation. So how to identify a positive correlation? We can see a positive slope or a slope moving upwards and to the right if there's a positive correlation. As the x increases, the y also increases. A negative correlation, we see a slope moving downward to the right. And in this case, as our x increases, our y decreases. And if we have no correlation, we have neither a positive or negative slope. So looking at this chart, we can see that there is a positive slope. So there is a positive correlation between hours worked and wages earned. And the meaning of that is that typically the more hours people work, the more they'll be compensated and paid for their time. So let's go ahead and write that down here. There is a positive correlation between hours worked and wages, because typically people are compensated or paid for their time. Alright, let's move on to the next page. Number 2, 30 students were surveyed what month they were born in and how many siblings they have, how many brothers or sisters they have. Now, if I graph this data, how would I describe the correlation? Well, is there a relationship between what month somebody is born in and how many siblings they have, how many brothers or sisters? Well, it seems hard to make a relationship or to think of a relationship between these two axes. We could maybe think of how many siblings somebody has and the religion of their parents. We could think of how many siblings they have and the income level of the family. Right? There may be a relationship there, a correlation. But the month somebody is born in doesn't have any relationship or correlation with how many siblings they have. So I'm going to say here, if I graph this data, then describe the correlation, I would say there would be no correlation because there is no relationship between birth month and number of siblings. for problem number 3, a graph depicts a student's height and the number of successful limbos. If you graph this data, describe the correlation and why. Well, limbo is where you have a stick and you hold it high up, music is playing, and people try to walk under the stick without bending forward. So they're bending backwards. And after everybody has gone under the stick once, they lower the height of the stick, and they do it again and again and again and again until the stick is very close to the ground. Now, if I was going to graph a student's height and the successful number of times they were able to limbo, would we see a relationship between these two axes? Yes, we would. Because at my last daughter's birthday party, we did play limbo, and all the adults lost quite early in the game. And all of the smallest children, they lasted very well into the end of the game. Okay? Because the shorter you are, the easier it is for you to get under the stick. So let's go ahead and put that down here. Right? There. Let's see. Height would be a negative correlation between height and limbos. And why would it be a negative correlation? Because the lower someone's height, the higher the number of limbos. So if we are graphing this, maybe I could do it right here. Our x-axis would be height, and our y-axis would be limbos. And so the shorter somebody's height, maybe we could start it off at 3 feet, 4 feet, and 5 feet. The shorter somebody's height, the higher the number of limbos. The medium student's height would have an average set of successful limbos. And the tallest person's height, they would have the lowest number of limbos. So what we see here on the data points is a negative relationship, a negative correlationship. As the x increases, the y decreases.